so my name's Liz. I am a co-founder of a startup called Microscaling Systems, and we're building some tools around containers. Kind of a quick show of hands, how many people are using containers? Oh, loads, that's great. Actually, can you put your hands up if you're using containers but not Docker? Oh, like, yeah, 3, okay, fine. So, let's just have a show of hands if you are using containers, or even if you're not using containers, and you think you've got a really clear grasp of what a container actually is. What does it mean to run a container? We should know, great. Yes, so a few of you. But I, until I saw a marvelous talk by the very wonderful Julian Friedman, I felt like I had an extremely shaky grasp of what a container is. You know, you hear people say things like, it's a lightweight virtual machine, and you think, what does that mean? Or you get people who go, oh, it's just jails and namespaces and C groups, and I don't know what you mean. What does it mean? And then I went to this fantastic talk by Julian. He has given me permission to copy it, because I am basically stealing it. It was so good, I went home, kind of wrote the code myself, explored it and thought, yeah, I have to share this with other people. So basically all the kind of clever work was done by Julian, and I'm just copying it. But hopefully you'll be able to learn something from it, because I know I certainly did. This is the obligatory picture of a container. I believe it's actually the law that if you're going to talk about containers, you have to show this. And we're going to try and blow it apart a little bit and try and understand what the container is really made of. Okay, so virtually everybody already in this room knows how to run containers. I'm just going to try and remind you what we're doing. So if I want to run something in an image that can't spell my own thing. Let's say we're just going to run echo hello. So Liz Rice image test is a very, very dull container that just contains Alpine, which is a little small Linux, and all I've done is ask it to echo hello. That's not very exciting, is it? I can ask it to run a shell. If I'm going to do this, I need it to be interactive. And I can say, okay, I'm in a shell, and I can see my own file system. That looks quite Linuxy, doesn't it? We can see what processes are running, very little. It's only showing the processes that are running inside this container. I can see a host name. That's just been allocated by Docker. It's a kind of random string. But that has no resemblance. Let's come out of the container, and that has no relationship to what's going on my Mac. It's isolated. It's separate. It's got its own file system. It's got its own process list. It's got its own host name. So what I want to do is recreate that. How do we create something that has these sort of isolated namespaces and what have you? You don't need to see me type in package main, so I'm going to start from like a few lines of code already. So what I did when I executed Docker was I did docker run, and there was a container name, and then I said some kind of command like echo, and maybe it had some arguments like hello, right? And in my program that I'm going to write now, I'm going to have to do go run to make it work. I'm going to run main.go. So that's kind of the equivalent of Docker so far. I'm going to have a run parameter. I don't need to specify a container because I'm not really writing anything for production here. I'm only going to have one container. And then I'm going to pass in a command and some arguments. Okay, so I'm going to make my program look as much like Docker run as I can. And let's do, the first thing we'll do is just print out what I'm going to run. So a new line, and we will print out the arguments that I have been given, just so we can see what we're doing. And then we are going to execute a command. And the command is going to consist of, the first argument is going to be run, right? Oh, no, I've done this wrong. This is going to be called run. And we're going to have a separate function called main, which needs some braces, obviously. And we're going to switch on that first argument that I nearly forgot all about. And if it's, oops, oh, that was interesting syntax, never seen that before. If it's run, then we're going to call run. And if it's not run, oops, we are going to fall in a big heap on the floor. Okay. So if we've been given run, we're going to come and call this run command, and then we're going to print out everything that followed run from argument 2 onwards. And it's going to execute whatever we passed in. We also have to connect up stood in, stood out, stood because otherwise it gets really, really dull. You can't see what's going on. Just take a second to do this. Oops, I cannot type on here, can I? Which is not great for a live coding demo. Stood out is the one I haven't done, right? By the way, I'm assuming this is big enough that you can all see at the back, right? Shout if you can't. Also, if you spot me typing a syntax error, feel free to shout out. That would be great. So having set up this command, oops.
Liz, it might be an idea to type at the top of the screen.
Yes, that's a good idea. Let's put some spaces down here. So we've connected up stood in, stood out, stir, and we're going to run the command. So it's not very exciting, but let's just see it happening. I'm going to actually do this in a virtual machine. It's an Ubuntu virtual machine inside my Mac. The reason for that is because some of the stuff that I do later is only implemented in Go Linux, not Go for OS X. So where am I? There's my main.go. So we can execute that. We're going to do run, and let's run. Say hello. Oh, what have I done wrong? Exec command. Cannot use that. Ah, I know. Yes. The exciting ... You should have shouted that out. You're all Go experts, right? Okay, so that was thrilling, wasn't it? We've executed a command. Oh, if you think that's good, you're gonna go wild later. Oh, right. Okay, so we can execute things. Let's see what happens if we execute a shell. It's kind of hard to tell, but now we're inside the container. You can't really tell because it looks exactly the same as the host machine at the moment. And we can see all the same files. We can see all the processes that are going on everywhere on my machine. This is not very isolated, right? We could even, let's have a look at the host name. That's my Ubuntu virtual machine. I could change that. That has taken, great. Quit out of the container. I'm back in Ubuntu world, and if I look at my host name, well, that was not a very secure container that could go and change the host name on its parent. We really do not want that kind of behavior from our containers. So let's stop that from happening. This is when we get into namespacing. So we can do some attributes. Oh, I'm going to need to import syscall. Oops. Too many S's. Okay. Let me put some more returns so I can type a bit further up there. That isn't supposed to be like that. That's supposed to be like that. Syscall. Sysproc attributes. And there is a nice thing called clone flags. Because we get, oops, flags. And the name of the first flag we're going to pass in is called clone a new Unix time-sharing system, that stands for, which sounds incredibly fancy and complicated, but the only really interesting thing inside Unix time-sharing system as a namespace is the host name. So what we're doing here is we're saying, when you execute this command, give me a new namespace for my host name. So we can save that. We can go and run it. And this time, if I type hostname something, and it's changed in the container, but if I quit the container and I look to see what the hostname is now, it's still Golang as I'd set it before. So we have isolated the host names at least. Okay, it's a start. The next thing I would like to isolate is the process IDs. So it'd be really nice if we could only see those running processes that are actually inside the container. And there's another one of these flags. And it's called new PID, process IDs. That seems nice, doesn't it? And we're going to try that. Let's clear this out. And if we run PS, oh, that's not very encouraging. We can still see all the same processes we were running before. That's not what we wanted. Okay. So it would be kind of nice if we could, from within the program, print out what process ID we're going to run as, process ID, get the PID. Right. Only at this point, we haven't actually created anything new yet. So what I'm going to do, there's a reason for that switch statement that we did before. We're going to have two versions. So we're going to have run come in. I'm not going to bother printing this out here. And instead of just executing the command directly, it's going to do basically the equivalent of a fork exec. Self, exe. So execute itself. Now, how does this work? I need to do appending some strings together. So, and I think it's something like this. Dot, dot, dot. Close that off. Have these. Right. So we're going to come into run. We're going to fork an exec, call ourselves, but this time, instead of coming in as run, we're going to have another case here where it's going to be called child. And here, we're going to run child. So we've created a new process here. So when I come into this function, which we're going to call child, we should have a new process, which we can print out and see what it is. Okay, making sense? Let's try running that. Oops. Surely one of these is... run. Let's just do run echo hello for nodes. Okay, so it printed out that debug statement after it had forked the process, and it's been given process ID 1. That sounds pretty good. That's the process ID of a new set of processes. But let's run the shell. Okay, as before, you can't really tell that I'm inside the container, but I am. We've got that process ID 1, but weirdly, oh, I think I'm running inside a container inside a container. Ooh, it's all gone meta. But none of those process IDs is 1. So something weird is going on. And what's actually going on is that PS doesn't actually, yeah, I was in a container inside a container. PS doesn't actually look at the list of running processes. It looks inside a directory called /proc, and it looks to see what's in there, and it prints out some stuff based on that. So for my container to come up with an accurate list of processes, I'm going to have my own file system and have my own /proc. And that sounds pretty cool. We're going to need that anyway, right, containers have its own file system. Okay, so if I look in the root of my virtual machine, I've got a host root file system there. I also happen to have, conveniently, oops, I think it's called that. Yeah, I've got another root file system that I can use. I just happen to have a copy of, I think, Ubuntu knocking about just for the purposes of this demo. So what I want to do is I want to use this root file system as the file system of my container. Okay, right. So we need to tell it that we are going to have a new file system. It's called new NS. I gather that stands for new namespace because this was the first flag they came up with, and they thought, file systems, that's the only namespacing we'll ever need. And then they added I don't know how many more. Okay. And we need to mount these now. So we're going to change the root to use that root file system. No. And we need to change directory into, if we don't change directory into root, it just gets extremely confused. So let's try that. Let's clear this off. I don't know, I think I'm in my host again. Go run main.go, run shell again. Oh. What did I do wrong? Oh, did I? What, in here? Yes, I did. You're absolutely right. So this needs to be in here. It's going to run. It's going to work. Okay. So some exciting things happened. We got something changed from green to red. That was very cool. And the reason why that happened is because it's picked up the new file system, and amongst other things, it's picked up a new bash RC file. So that's pretty cool, and I can see I'm in the root file system. Awesome, I've got the right file system. So presumably, I can now look at my list of process IDs. Oh, nearly. But it just tells us what to do, so we'll just do that. So we have to mount this. I'm sure there's a reason why all these things are called proc in a particular order, but just... One day I'll look that up and then I'll forget immediately. Right, so let's run that again. Right, we're in our root file system, and we have the correct process list. Woohoo! So that's actually pretty cool. We have isolated a container running. It's, it thinks it's got its own set of processes. It thinks it's got its own file system. You can kind of imagine how you can keep on down this path to add, like, users, groups, have those all isolated from the host machine. The key thing is, all we've really done is we've started a process. So that's really all the container is. It's just a process, and it's just pointing at, it's got its file system that's somewhere in the host machine. I just think that's so much clearer when you see it executing. Okay. So, what I've talked about is namespaces. There are a few others. As I mentioned, there's users and groups. You'd probably want to have an isolated networking stack for your container. You don't necessarily want your container processes to be able to just communicate with random other processes on the rest of the host machine. But that's kind of all it really needs to do. There's also the concept of control groups. So if namespaces tell us what the container can see, the control groups is saying what resources the container can use. So you might restrict containers to only use a certain percentage of CPU or only use a certain amount of memory or have permissions for different devices. We don't really need to kind of see that running. You can imagine how that's going to work, right? So that's it. That's all a container is. It's pretty cool, pretty easy. I don't know what Docker is worth, but perhaps that's not quite production quality code. I will grant them that. There's probably a little bit more to it than that. Okay. So how are we doing for time? Okay. We've created a container in 20 minutes. Right. So very quickly, I just wanted to mention images. So you remember how we mounted, or we kind of pointed the container at a root file system. And that root file system is essentially what you have in a container image, plus you have some configuration. So when you put an image on Docker Hub, it's here is the file system, and maybe here are some environment variables, or here are some ports that I want you to be able to use. But that's what a container image is. And then when you run it, you're instantiating a container that's running that code. So that's all pretty simple. I think I have time to put a little plug in for something we've been working on called MicroBadger, which lets you explore the metadata and the contents of different container images. So this is that container I ran at the beginning, which has basically just got Alpine in it. So I've got Alpine, and I added myself as a maintainer. That was all there is in that particular image. You can go to MicroBadger and look at the contents of any public image on Docker Hub, and we would love your feedback. It's a kind of new thing, so we'd love your feedback, and hopefully you'll find out some interesting information about some containers on there. If, like me, you saw that and thought, well, that's pretty cool, I want to write a container, Julian's original container gist is available online. His version is very slightly different to mine, which you can compare and contrast and see which version you prefer. And as I say, we'd love you to tell us what you think of MicroBadger. I will be around, so you can grab me for questions, or you can tweet at me, or tweet at myself and my two co-founders at Microscaling as well. I really, really hope that has illuminated what containers are for you, as it did for me when I saw Julian do that. Thank you very much for coming.